Okay, go ahead. 张希，你可以开始了。
Can you hear me?
Yes.
Okay, it's clear finally. Okay. All right. So I'm wait. Can you go to presenter mode? So this is I think this is the for the presenter. This is not for showing.
Okay.
The other mode. Yeah.
你需要换页跟我讲，我帮你切吧。
OK， 所以现在声音是 OK 的是吧？
对，你要讲中文、英文都可以。Go ahead。然后你要切换页的时候告诉我。
Okay. So I probably just start with the English since the slides is English. So hello everyone. So my name is Zhangxi Tan. I'm a co-director of RIOS Lab at TBSI. So today I'm going to present the basic RISC-V instruction set and also a newly founded lab at Tsinghua-Berkeley Shenzhen Institute. It's called RISC-V International Open Source Laboratory, in short RIOS. So next slide, please. Okay. So RIOS is like a typical Berkeley lab. It's a 5-year mission. Just the goal is just to help to raise the RISC-V ecosystem to the state of the art. So it's a non-profit organization. Our focus is mainly focusing on technology transfer. And one of the important work of RIOS is we're trying to produce industrial quality open source IPs, just how people doesn't have any legal lawsuits. So let me give you a brief introduction about TBSI. TBSI is like Tsinghua-Berkeley Shenzhen Institute. It's founded in 2014. It's a joint venture by Tsinghua University and UC Berkeley. So we're teaching RISC-V and also have graduate courses on RISC-V and processor designs at TBSI. And our goal is just trying to produce the future leaders in technologies. So the lab is actually, we have one director led by the Turing Award winner, Patterson. And I'm one with co-directors, and also I'm a PhD student with David before. And another co-director is a Tsinghua professor called Lin Zhang. It's geographically distributed lab across the globe, and the primary location right now at this moment is Shenzhen. It's founded by the Shenzhen municipality funding and plus industry fundings. So Imagination Technology is already a member of RIOS, and also Western Digital and Microchip has already expressed the interest. So it's a joint effort by many companies and also with the university endowment. So next slide, please. So what are we working on? We're working on a thing called RISC-V open source open ISAs. So yeah, probably just show everything here. Okay, so so let me give you a little bit history about RISC-V. So RISC-V was actually we designed it around like 2010. That's the time I was at Berkeley. So by the time we were thinking, what would be the perfect instruction set for the research. So we look at ARM, we look at Intel x86. We found there are a lot of issues. First, it's very complex, and also there are many like IP issues, legal issues. And then in the end, we decided in the summer, say, hey, why don't we just develop our own, creating the clean slate ISAs. And 4 years later, we have the first spec ready, put out in the community. That's how we get the RISC-V. And the funny thing is, still in the process of like pushing RISC-V to the spec is initially we developed everything for research for class, but we start figuring out that people like start complaining, especially from industry people start complaining some like features issues on the RISC-V. Then we think it's probably the time to bring the RISC-V to open community. So that's the kind of original story of the RISC-V. So next slide, please. Okay, so what is different about RISC-V, right? RISC-V is actually 5th generation of Berkeley RISC processor. So there are a few features. First of all, it's free and open, so anyone can use it, and then, which means there are a lot more computations and also lead to more innovations. And you can pick a free ISA, then you can choose the vendors for providing ISA implementations. And also RISC-V is really designed for both cloud and edge. It's from large and also for a small computer, tiny computer, and microcontroller as well. And RISC-V is under the model of everything is open, so it's secure and trustworthy. And everyone can design your own core, and open means there's no secret. So if you have any security flaw, anyone can help you point out. And RISC-V, one of the big features is very simple and elegant. So it's after 25 years of the first generation of RISC. This is almost the 5th generation, and it's far simpler than ARM and x86. And one important feature of RISC-V is like the baseline is very simple, and will allow you to add custom instructions. And also, we took a lot of input from software and architects before we really finalized it, I'd say. So I have to say it's very technically, summarized pretty much the past 25 to 30 years experience, and looking at what people have done wrong, and that's pretty much a clean slate design. And also, there's a large community just getting involved in RISC-V, and after pushing on the standard, we set up a RISC-V foundation just to help to maintain the ISA maintenance. That's the standard. So technically, RISC-V is really owned by a foundation. So it's not really owned by UC Berkeley. It's owned by a non-profit organization headquartered in Switzerland at this moment. So next slide, please. You probably read a little bit, the news about RISC-V. I'm not going to go through the details of the news here. And so basically, they're kind of like the published 3 articles in The Economist late last year, just talking about the open season, fact in India, and also your own RISC. So basically, just to sum up, RISC-V is kind of like the hardware open source effort, like what you have seen in open source software. And it started with us from the Berkeley, and there are actually 2 reasons that people summarize. People are moving more and more towards RISC-V this year. The first reason is economy, right? Because RISC-V is open, so it really competes against a lot of closed source design, specifically from ARM. So we can really compete with ARM with a lot lower price and also much better implementation. The second is like geopolitical reasons, as we can probably see recently, another tactical war is really going up. And so choosing an open source design, open source architecture will really help everyone, especially during this stage. So next, please. So far, there are more than 400. I think I'm looking at a recent number, last month in Switzerland, the RISC-V International. I think this number is slightly outdated. It's at the end of Q4 2019 last year. It's really close to, I would say, somewhere around like 500 to 600 companies and also universities. So within all the people, all the entities that participate in RISC-V, we have a lot of people from chip design companies. We also have companies from software designs, and also we have people from different industries, from cloud computing for mobile space, HPC, machine learning, and automotive. And also of course, from people from research universities and the labs. And also there are some design services as well. Like there are 31 design services under the RISC-V International. So it's really a booming community at this moment. So next one, please. So when we were talking about RISC-V, there are a lot of confusions between ISA and also the free and open source hardware, right? So RISC-V by itself, we can say it's just a standard, it's a specification. Basically, the instruction set architecture, right? And let's use a similar term, because given that people here are pretty much a software community, let's use the term of open source software so you probably understand.
Hi, we cannot hear you.
Hi, we lost your voice.
I will try it. Okay. Okay, go ahead.
Okay.
Yeah.
Yeah, so maybe I can use WeChat. That's probably the better if that works for you.
Yeah. So can you see? Is this slide the right one?
No, that's not the right one. Please go back. I haven't finished everything.
Okay.
Yeah, because I don't know why Zoom doesn't work here.
Okay, go ahead.
Yeah. Okay. Can you go back one more slide?
One more.
Yeah, go back. You're a little bit ahead of me.
This one? I think you already go through.
No,
That's
no. I'm talking about free number. Okay, number 7. Can you go to slide number 7?
Number 7. Okay, hold on.
Yeah.
This one 6.
Your screen is not changing anything on my side. I don't know why.
Okay, it's on number 7 now. So.
Okay, doesn't matter. You can display slides. I probably just talk over the WeChat, right?
Yeah.
Sorry about this. I can use the slides on my screen, so that'll be better. Okay, so we talk about difference between the specification and also the open source hardware, right? So even the people here that are more in software community, so let me use the analogy in the software just to explain the difference between the ISA and open source hardware. So we talk about specification. Basic RISC-V is just a specification. It's not a implementation. This is similar to the software world. It's POSIX standard in software. And another concept in the RISC-V is called design, which is software world. It's called like source code. So for example, you will see RISC-V, Berkeley design Rocket. So that's a implementation. This is similar in software world. So for example, Linux in software, right? And another, dimension when we talk about the specification, talk about the ISA and hardware is we talk about products, right? For example, people can make RISC-V products, right? And also companies like Red Hat, right, can make like Red Hat Linux for a software product based on the open source Linux. And if you look at the specification of designs, there are really 3 types. Now I'm using the colors of traffic light, green and yellow and close, just to indicate, the openness of each different, implementation. So the first one is free and open, which means there's no fee, anyone can use it. And you can actually design yourself and share your design with anyone else. There's no legal issue. You don't have to pay anything, it's free. The second one is licensable. This is the most, one of the most common approaches from the companies, right? Company like to develop licensable designs, licensable specifications. They own the design and own the spec, and other people have to pay a fee to use it. You cannot easily share it with others without some agreement with the company who invented it. And the last one is the closed source one. This is the most another very common one. So company owns everything, no one else can use it. It's completely closed. So next slide, please. So let's, if we put like this specification, talk about, and also designs, we list them in a 3x3 column, free and open spec, and licensable spec, and closed spec. And similarly, can you show the next slide, slide number 9? Yeah, similarly, you can have free and open designs, and licensable design, and also closed source designs as well. So next one, please. So if you look at the closed source design, right? The closed source design, you can have a closed spec and closed design. So this is very similar to what Intel is currently doing, right? So next slide. So number 11. So licensable spec is ARM is one of the most famous licensable spec, and you can have either a licensable design but also closed designs. So in order to license a ARM design, you have to pay probably around $5 million, just plus about 4% of the royalty fee, right? Because every time you make a chip out of it, so ARM will collect about 4% of the money you sell to the vendor. So, and also some people can also buy the license, license spec from ARM, just for example, like Apple, right? And they're making their own closed designs. And Qualcomm did that before. iPod did that before. The number used to be on the slides here, it used to be about $25 million, if I recall correctly, a few years ago. But recently, we talked to some people, ARM started, SoftBank is running into trouble. It's trying to jack up the price a little bit more. What we heard, the recent number is about like $50 million, and also charged based on number of cores you like to put in your design. So it's going up. So next one, please. And a RISC-V, it's currently, will fit in this like the free and open stack. There are a lot of like open source designs, probably about like 20-ish open source designs out there on the market. And also we have seen licensable designs as well from RISC-V. You can buy from Sci-Fi. You can buy from some other companies. I think Alibaba recently they have something you can license as well. And also there are some companies that are bringing closed source designs as well. And so, but free and open doesn't mean you cannot have a commercial product. So next one. So let's say number 13. So this slide basically lists the number of designs we have seen in this space. So closed specs, which is x86, we're roughly seeing about like 15 designs. And ARM designs, licensable about 20 licensable design and 25 closed source designs. RISC-V, about like I mentioned, 25 roughly around 25 open designs, and also about 50, almost has the highest number of licensable designs among all probably the processors I've seen these days. And also we're also seeing like about 25 closed source RISC-V designs as well. So why there are so many processors, right? So next slide, please. So number 14. So first of all, it's just like building a car, building a race car, right? Microprocessor is just like the engine of a car. Right? It's really the most fun part to build when you build a computer. And people like to build cars and then improving based on engines. But if you're talking about building a real computer or real car as an analogy, you need a lot more beyond the engine, right? So for example, if you build a car, you need the steering wheel, you need the pedals, a fuel tank, your speedo, and mirrors and lights, and so on. So next one, please. So this slide, we actually choose from one of the top conferences written, and it's called ASPLOS, right? It's usually where the computer architectures and the software guys, OS guys, and talk to each other. So there's one paper just talking about the cost of other parts, in your computer, other than your CPUs in different process technologies. So this is slightly old, about probably the data from 2016, but still show you the rough ideas about how much more expensive when we're moving up to a more advanced nodes, and the other components will cost. So DRAM controller, it's about what cost, consistently cost about $125,000. And if you, that's not just the controller. If you really want a working memory controller, and if you have to include the controller, also the PHY together, so that will going up to almost $1 million just get your efficient memory controller ready. And PCI Express, that's one of the important I/O controllers on your CPUs. That's roughly what costs about the same amount. And also their I/Os are getting more and more expensive too, because the speeds are more and more expensive over years. So for RIOS, we're trying to look at, so this will give us some ideas is we're not have to just look at the CPUs. We need to really look at all the components and how do we build a computer, really open source computer, just have all these parts in it, right? Because we're trying to build a car, we'll not just build an engine. So next one, please.
We are running out of time, so you might need to make a conclusion.
Oh, okay.
Yeah,
so I probably just jump directly to slides number 18, maybe. That's probably the one I want to talk a little bit. Okay. So I realized what we're trying to build is, like I mentioned, we're trying to improve the ecosystem. And one of the approach that we have done is we're trying to have this vertically integrated project we call Pico Real Platform. So this is the platform similar to Raspberry Pi, and it's built everything with open source IPs, but with very good documentations. It has, and also have the industrial quality, like I mentioned. You want to have this thing to be other people to use. So we're basically trying to release this, everything under a open source license, very similar to BSD and or Apache v2. RIOS will be monitoring and are doing architecture development, and we're working with design houses just to get the whole thing we'll build. We're trying to produce this platform more like a RISC-V versions of Raspberry Pi in high volumes. And was also working with a lot of other companies just trying to get this thing to everyone. So next one, please. Number 19. So we're planning 3 phases of Pico RIO. So Pico RIO 1.0 is what we're going to put in the public around in fall. So it's a quad-core Linux-capable hardware. It runs Linux. Also, we're trying to run a command line version of Chrome OS, Chromium OS. And we're trying to make the first announcement in September. That's the time when we had the RISC-V Global Forum. And version 2, it's the phase 2, is we're adding a GPU, we're adding graphics in it. This is the work, a joint effort with Imagination. So we're taking a graphics a processing unit, put in the Pico RIO. And also trying to run a lot more applications, for example, trusted hypervisor and some management, runtime like WebAssemblies. And version 3, which is the kind of final phase of the Pico RIO, we're trying to build a Chromebook-like computer systems, right? So that will involve a little bit better performance, and the more IP will be open source. So slide number 20. So if you look at the whole software side, this is what we're trying to run on the Pico RIO hardware. So we're focusing on trusted hypervisors and also secure firmware. And recently, we'll get the Chromium trusted firmware ported to RISC-V. We'll plan to open source this pretty soon in August. And also, we're leading actually another effort is it's getting the RISC-V port of Chromium OS working on RISC-V. And also, our goal is trying to support the run is like progressive web applications, and also eventually getting the Android apps through the Chrome. And another work I'll probably just talk to the next slide a little bit is the JavaScript engine, right? And also WebAssembly work for RISC-V. So Wei-Fen, please, next slide. So this is recently, I think a few weeks ago, we open sourced a Google V8 RISC-V port for RISC-V, the V8 JavaScript engine. So V8 JavaScript engine is actually completely written in C++. It's an essential part of the Chrome browser. And also it's kind of a foundation of Node.js. A lot of applications like your Visual Studio Coder is built on Node.js. You can either run V8 as standalone applications, or you can embed V8 inside your browser. And also we're trying to add RISC-V 64-bit support to to the V8. It's actually a joint open source work by RIOS Lab and also the membership companies. Started very early this year, like January. We spent almost like 6 months. Lately, we involved some community efforts. So there are another team actually in China. They're been working on a V8 port. They joined us in last week. So, and we support RISC-V 64-bit. We passes pretty much over like 94% of the standard V8 test. Planning to support 32-bit RISC-V support soon. And also we're talking to Google. So we're trying to get the whole RISC-V port, upstream pretty much in fall. And so I'm listing the Git repo here. If anyone's interested, you can actually go there. It's really open community right now. We have our Slack channels and the regular meetings, bi-weekly meetings. We're also looking for hackers just to help us just, making this to be more like a production quality, so we can really get the whole thing upstream. So final slides. I'm really sorry about, the technical difficulty. So just in summary, RIOS is a 5-year nonprofit project done by Tsinghua-Berkeley at TBSI. Our goal is trying to produce industry quality, IPs, and trying to elevate the ecosystem of the RISC-V.
Yeah.
And the RIOS, because we're from California, so RIOS is the Spanish word for rivers.
We need to move on to
Hello?
next session. So I'm sorry, but we got to wrap up now. So.
Okay.
Yeah.
So I think pretty much that's it. Real. Yeah.
Yeah. So do you mind I share the slides to the community?
Yeah, you can feel free to share the slides. Yeah.
So thank you. We got to move on to another session. So I will talk to you later.
Okay.
All right. Thanks.
All right. Thank you. Bye. Thanks. Bye bye.
All right.